Welcome, I'm Justin. I want to pass you through constructing triangles, quadrilaterals using GeoGebra software. I have my GeoGebra installed on my PC, this one. If you do not have it, download it and install it on your PC and open it, double click, and you can see my page has opened. I do not need the grids and the X and Y axis, so I need to make them disappear by coming here and grid, show grid. That's one way of getting rid of the boxes or the grids. Y axis, we don't need the Y axis. We don't also need the X axis. So once that is done, you can see we have now our plain page. And now we are going to work with a question from one of the ECZ past papers, School Certificate 2018 GCE. Construct triangle PQR in which PQ is 10 centimeters, QR 8, and angle PQR 50 degrees. Okay, so let's start by drawing the line PQ. We go back to our GeoGebra. Now drawing a line, we need to come here and come to segment with given length. So that's a line with a given dimension. So we need to click where our line would start from and mention the length of this line and say OK. So that's our line, 10 centimeters, and you can see there is point A and point B. Now our triangle is called PQR, so we need to change A into P. So we say rename. This one is supposed to be P, and say OK. Also, this one renamed to Q. Yes, say OK. So finally, we have our line. The default name of this line is F. We do not need this name, so we say show label. You can see the F has disappeared. And now, looking at the question that we are given, we have drawn the line PQ 10 centimeters, and now we have to draw also QR, line QR 8 centimeters, but we can't draw this line before we draw this angle PQR 50 degrees. So this angle is between PQ and QR 50 degrees. So PQ and Q are somewhere and it's 50 degrees. So again, there is a way of drawing specific angles. So we need to come here and say angle with given size. So angle with given size, we click and we say we select a leg point, the vertex, and the angle, we feed the angle there, it's 50, and the angle will be at Q, and this angle would be it would be clockwise, and say OK. So you can see our angle 50 degrees has been drawn, and you can see there is that other arm where the other arm is supposed to pass through, and having drawn angle Q, and now we can now draw our line QR, which is 8 centimeters. So QR is supposed to run from here, Q, to R there. That one will be changed to R. So again, we come to here and say segment with given length, and our start point, the length is 8 centimeters, and we say OK. So we have we are given that line is from here to here. This is actually 8 centimeters, and we need now to move this one. We need to move this arm, move it like that, following the angle. The angle is 50, and we know our 50 degrees is there. Yes, so like that. So that is this is where our R supposed to be. So we rename that point as a capital R, and we do not need this name G, so we say show label, and you can see our angle here 50 is not where it's supposed to be, so we can actually move it inside here, and I'm sure we are able to see that. And whatever else we can move, we can also move our P to the side, and this one we do not need it, so we can leave it, or we say show label, so that that one disappears. Okay, we are told now that PQ is 10 centimeters. So we can go to where I've gone and say text, so that we put our 10 centimeters here. So we say 10 centimeters, okay. And also here, a QR is 8 centimeters. Also we write there, and you can see our 8 centimeters is there. And finally, our work is just to close this space here by a straight line. A straight line is just a segment, and to start from here and there. And so by that we would have constructed triangle PQR, where PQ is 10 centimeters, QR is 8 centimeters, and angle PQR is 50 centimeters. Now there are times when, for example, we are asked to measure and write down the length of PR. We could be asked to measure and write down the length of PR. So what we do, we need to go to here and come to distance or length. Then the distance we want to measure, the length we want to measure is the length of PR, and here. So you can see it has been generated automatically. The length of PR is 7 centimeters. So basically, that's how we measure lengths when we are in GeoGebra. So this is it. So we can move on and look at the other part of the question. And for example, we were told to measure and write down the length of PR, which we have done. Okay, now we need to draw these loci equidistant from P and Q. Equidistant from P and Q. Locus of points equidistant from P and Q. So basically, that's a perpendicular bisector of line PQ. So the way we draw a perpendicular bisector in GeoGebra, we come to here and say perpendicular bisector. So now we pick the points that we are going to bisect. It's point P and point Q, and we are able to see our bisector like that. Okay, the other question, the other locus is equidistant from PR and PO. Equidistant from PR and PO. Equidistant from PR and PO. So equidistant from PR and PQ. So to say, equidistant from PR and PQ. So equidistant from PR and PQ is an angle bisector. We bisect angle RPQ. So the way we bisect this angle, again we come to here and we say angle bisector. Which angle do we bisect? This angle, or we bisect the angle. We mention the legs and we bisect angle RPQ. So this is the bisector of angle RPQ. Okay, the other question, the other locus is 5 centimeters from R. So we go to GeoGebra, R is there, 5 centimeters from R. That's basically a circle of radius 5. So we come here, a circle with center and radius. So that's where we are. Circle, center is R, radius is 5, and we say that. So finally we have that one, and we can actually label our loci. We can say this one is equidistant from PR and PQ. Okay, so and this one is 5 centimeters from R. Okay, successfully named. And this one is equidistant from P and Q. Okay, so we have the loci, all of them in. If we want to move anything, we can move this one can be moved somewhere here, and this can be moved here, and this one can even be moved this side. Okay, our R is not also it can be moved there. Yes, okay. Then PR is actually this one. PR, yes, it can be put there. PR, yes, it can be put there. Okay, so now, once that is done, we can move on to the next question. We are told a point T within triangle PQR is such that it is 5 centimeters from R. So that point T within triangle PQR is 5 centimeters from R. So 5 centimeters from R, it means it will be along this circumference of this locus, which is 5 centimeters from R. So it will be along here. It will be along here. Yes. Then again, we are told and equidistant from P and Q. And equidistant from P and Q. Equidistant from P and Q, it's this locus. Equidistant from P and Q. So the point in question, it is this one. So we can put the name of the point. We are told that the name of the point is T. So we can write T here, capital T, and you can see our T is there. Okay, so this is our point T. Okay. Part D, another point X is such that it is less than or equal to 5 centimeters from R, less than or equal to 5 centimeters from R, and nearer to Q than P, less than 5 centimeters from R, so it is this side here. This side, and nearer to P than Q, so left of this locus here, this side. And finally, we are told nearer to PQ than PR. Nearer to PQ than PR. So it is actually this point, this is where the point X must lie. Okay, so now we are told to shade this region. So now the way we shade, we come here and we come here and start shading. We shade. No. So first of all, so we shade. We come here and say polygon. We start shading. First, putting the boundary of the region we want to shade. Okay, so we want to shade this region, and we can actually change the color of that region because we are told to shade and let it be that. Okay, so like that. And now we do not need these so we say show label, show object. So when we say show label, we would have removed the actual point. Show label. So when we say show label, we would have removed the actual name of the point. And when we say show object, we would have removed the. Okay, so basically this is the region that we wanted. Again here, show label, we don't need that one. So this is the region which we are told is where X is supposed to be. Yes, we can even do this one. This point we don't need it. We say show label, and this one we don't need it. Show label. This point also show object, also show object. Okay, so basically this is how we do construction using GeoGebra. This is how we do construction using GeoGebra. When we want to draw a line of given length, we come here. When we want to bisect a line or an angle, we come here. When we want to draw a parallel line, we come there. When we want to draw a circle, we come there. When we want to measure anything, we come here and measure, and basically this is what we are able to do on GeoGebra. And we are also able to do other things. For example, we are able to do transformations here, where we are able to reflect points, and we are able to rotate, we are able to translate, also we are able to enlarge. Yes, so we can also rotate, reflect, translate, and dilate points. So basically, GeoGebra is very helpful, so that we do not practice, and whenever we practice for a day or two, we tend to stop and we forget everything that we might have learned. I almost also forgot how to change this color here. Let me just say we need to choose color, and I think I need to recall this one. Okay, thank you.